Next, we would like to welcome David Delli Zotti on stage, who investigated the effectiveness of biodiesels made from different vegetable oils. Let's see what he found out.
In finding the most combustible biodiesel made from the following vegetable oils: olive oil, sunflower oil, sesame oil, corn oil, and canola oil. So the basic reaction is transesterification reaction, and basically what we do is, well, what I did is I mixed methanol with sodium hydroxide, lye more specifically, and then added it to a solution of vegetable oil, one of the 5 I tested. And basically this gives the methyl esters, which are the biodiesels, and the glycerol, which is a byproduct and can be used for soap manufacturing. So why are biodiesels better than regular fuels? So first of all, biodiesels are clean burning, meaning they produce very little amounts of carbon monoxide and soot. They are renewable also, meaning that the rate at which they are produced is smaller than, is greater than the rate at which they are consumed. And it increases energy security because it's affordable and it's always available. And finally, it can be made from food waste. We can see here that in Luxembourg, 70,800 tons of food, there's 70,800 tons of food waste during the 2018-2019 period. And globally, there's around 2.5 billion tons, or 1/3 of the total food produced. So basically, each olive oil, so from the reaction, we can see at the top, which was in the first slide, it's actually the fatty acids in the triglyceride that form the biodiesel. And so this is the fatty acid content in each of the different vegetable oils, which determines which one is a better biodiesel. So as I stated before, I first mixed 4 grams of sodium hydroxide with 50 milliliters of methanol, and I mixed them with a magnetic stir for around 2 minutes. Then I added, well, then I heated up 200 milliliters of the specific vegetable oil and added it to the solution of, to the methoxide solution, which is the sodium hydroxide and the methanol. Then we mix it for 30 minutes with a magnetic stir, and we leave it to rest for 24 hours in a separating funnel. And then what we observe is that the glycerol forms a layer at the bottom, and the biodiesel forms a layer at the top. So the next step is to purify the biodiesel. So what I did is I heated water to 30 degrees and added it to the pure biodiesel solution. So the glycerol was already removed from the biodiesel. And basically what happens here is the biodiesel is hydrophobic, therefore the water passes through the biodiesel and takes the impurities such as the unreacted methanol or unreacted sodium hydroxide. And it forms a layer at the bottom, which can be separated again if we put it in a separating funnel. So to measure the change in combustion, I did a calorimetry experiment with the formula delta H equals negative MC delta T, where M is the mass of water, in this case 20 grams. C is the specific heat capacity of water. Delta T is the change in temperature of the water, and basically once the value was calculated, the delta H value, I divided it by 1,000 and I divided it by the moles that combusted. I measured the difference in mass to get a value in kilojoules per mole. Like any calorimetry experiment, there are a lot of uncertainties, such as heat loss to the environment, heat absorbed or released by the apparatus, and yeah, many other uncertainties. So the safety and environmental hazards. So when I mix the sodium hydroxide with the methanol, it forms a methoxide solution, which is a nerve agent, so it's very important to be safe with it. So I worked under under a fume hood, and basically I was wearing the safety equipment necessary, so goggles, lab coat, the safety gloves, and yeah, I was be careful of my surroundings. Then there are no environmental hazards, as all the chemicals produced were disposed of properly by a lab technician in my school, and there was no testing on animals, so no ethical issues. So the results, as we can see from the blue graph, the biodiesel, the olive oil biodiesel, was the most combustible. It had the greatest delta H value, negative 573.85, but this is debatable because all three of the biodiesels made from sunflower oil, olive oil, and sesame oil have a high standard deviation due to the calorimetry experiment, as it has a lot of uncertainty. And yeah, so we know that these three are quite good for biodiesel synthesis. The canola oil wasn't as combustible, and despite multiple attempts at producing the corn oil biodiesel, none was produced, meaning, yeah, that it's unsuitable for biodiesel synthesis. Yep. That's all.
Hello, David. Thank you so much for joining us, and congratulations for your performance on stage. How happy do you think the jury was with your presentation?
I think they were quite happy. I think because I did a lot of experimental work, yeah, they were quite happy because of the presentations in front of me didn't do as much. They did more research-based projects, so I think they were quite happy to see a more experimental project.
Nice. And how were their questions?
I thought they were going to be harsher, but no, they weren't that harsh with me, so I'm happy. Yeah.
Good. And maybe did the questions inspire you in any way? Did they have ideas to develop or to do anything different?
Yes. One of the questions, one of the people in the jury asked me why the canola oil biodiesel wasn't as combustible. Because it has the same amounts of fatty acids as the other biodiesels, or as the other biodiesels made from vegetable oil. So yeah, I'm gonna look into that because I haven't asked myself that question yet. So yeah, I'm gonna do some more research on that.
Great. So do you plan on developing this project and maybe present next year again?
Yes, I will either look into that more and yeah, develop this project, or I might start something new.
Great.
Something completely.
Can you tell me a bit about where this project all started? Where did you get the idea?
Well, I was at school, and yeah, I think we were watching this presentation. It was last year. We were watching this presentation about food waste, and yeah, I asked myself, what can we do with food waste? And so I searched it online, and one of the first things I saw was make a biodiesel. So yeah, making biodiesel. So yeah, I looked more into it, and it was quite interesting because it combines chemistry, which I like, and biology. So yeah.
Okay, and how could this topic help us solve this waste problem?
So biodiesels, they can be made from food waste, of course, as I stated, and yeah, so basically, we're not only making a renewable fuel, but yeah, we're also using food waste. Yeah, and there's a lot of food waste, as stated in my slide.
Great, thank you.
So this is now your second project, right?
I haven't presented yet. This is my first time presenting, but I have other projects. But yeah, this is one of I would say my second project. Yeah.
Okay. So the different project that you're working on, how do you think, or how would you explain that they impacted your perception of your surrounding, your life, and also maybe of your future?
Yes. Well, I thought that food waste, was quite important to. It was an important problem to tackle, especially what to do with it. Most of it is not used, I think that it gave me motivation to do this project, and also I would say, I thought it was a good cause, and I think that opened my eyes kind of into the waste that we are producing all the time as humans.
Okay, great to hear. And I hope that we find a solution. Mm-hmm. But you were talking about later on that you might pursue your projects in the future. Mm-hmm. Would you say it's something that you want to make a profession out of it? Is it something that you want to study towards? Or is that something that you want to keep as projects, as a side hobby project?
I would say more as a project, but who knows? Maybe I might look into it later in my life. So I don't know. I'm not sure yet. But I think for now it's more of a project.
Okay, but then thank you very much for being here.
Thank you.
And maybe you're going to be here next year again?
Yeah. I'll for sure be here next year.
And we are looking forward to it.
Yes.
Thank you
so much.
Thank
Thanks.
you.